Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from Chapter 10, Wave Optics. Let's move to first question. In a Young's double slit experiment, if there is no initial phase difference between the light from the two slits, a point on the screen corresponding to the fifth minimum as path difference dash. Del is the path difference formula. Del equal to 2n minus 1 lambda by 2. That is for minimum path difference. For that formula is odd integral multiple of wavelength, that is delta equal to 2n minus 1 lambda by 2, and n equal to 5 is given. N equal to 5. Substitute this here. Del equal to 2 into 5 minus 1 lambda by 2. 2, 5, 10. 10 minus 1, 9. 9 lambda by 2. That is, del is 9 lambda by 2. Option C. Option C is the correct answer. Let's move to question number 2. In a double slit experiment, when light of wavelength 400 nanometer was used, the angular width of the first minima found on a screen placed 1 meter away was found to be 0.2 degree. What will be the angular width of the first minima if the entire experimental apparatus is immersed in water? Given mu, that is refractive index of water, is given 4 by 3. Formula is theta equal to beta by d, and this is for air medium, and theta dash equal to beta by mu d, this is for water medium, and mu is given 4 by 3. Then what you want to find? You want to find theta dash, and given data theta is given. Theta is given 0.2 degree. Then theta dash by theta equal to beta by mu into d into beta by d. Then this beta d getting cancelled. What's the remaining thing? Only mu, that is 1 by mu. Theta dash by theta equal to 1 by mu. Then theta dash equal to theta by mu. Theta by mu, and mu is given how much? Mu is given 4 by 3. Given data, mu equal to 4 by 3. So 1 by 4 by 3 is 3 by 4. Then substitute this here. Then 3 by 4 into theta. This theta goes there into theta. Value of theta 0.2. What's the value of 0.2? If you cross multiply this, 4, 5, 20, 0.05. Then 3 into 0.05 is, yes, 0.15. 0.15 degree. That is option A. Option A is the correct answer. Let's move to question number 3. In Young's double slit experiment, the slits are 2 millimeter apart and are illuminated by photons of 2 wavelengths. Lambda 1 equal to 12,000 Armstrong and lambda 2 equal to 10,000 Armstrong. At what minimum distance from the common central bright fringe on the screen, 2 meter from the slit, will a bright fringe from one interference pattern coincide with the bright fringe from the other? Formula, first formula is n1 lambda 1 equal to n2 lambda 2. From that, find n1 by n2. n1 by n2 equal to, what's the formula? n1 by n2 equal to lambda 2 by lambda 1. Lambda 2 by lambda 1. Lambda 2 is 10,000 Armstrong. 10,000 into 10 power, better I'll write it down. That is equal to 10,000 Armstrong, 10 power minus 10 divided by lambda 1 is 12,000. 12,000 into 10 power minus 10. Then simplify this. 10 power minus 10, 10 power minus 10 getting cancelled. These 2, 3, 0, these 3, 0 getting cancelled. Then use 2 table, 2, 6, 12, 2, 5, 10. Then n1 by n2 equal to 5 by 6. n1 by n2 equal to 5 by 6. 5 by 6. Then question is, at what minimum distance from the common central bright fringe on the screen, 2 meter from the slit, will a bright fringe from one interference pattern coincide with the bright fringe from the other? Formula is x minimum equal to n1 lambda 1 d by d, and n1 from this, n1 by n2 equal to 5 by 6. Then n1 5. So 5 into lambda 1. Lambda 1 12,000 Armstrong. Convert that Armstrong into meter into 10 power minus 10. Okay. And then d. D distance is, where is it? 2 meter into 2 by small d. Small d is 2 millimeter. That is 2 into 10 power minus 3. Then cancel the somethings. 2 getting cancelled. 10 power minus 3 comes up. 10 power plus 3. Then x minimum equal to 5, 12, 60. Okay. Into 10 power 3. The 1000 I am writing as 10 power 3 into 10 power minus 10 into 10 power minus 3 comes up 10 power plus 3. Okay. Then it gives 60 into 10 power 6 minus 10. 10 power minus 4. 10 power minus 4. Answer is given in millimeter. So 10 power minus 3 is millimeter. Then 60 into 10 power minus 3 into 10 power minus 1, that you can write as 6 into 10 power minus 3 meter. This is equal to 6 millimeter. 6 millimeter. Which option? Option D. Let's move to question number 4. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of dash. Yes, it should possess small focal length and a large diameter. Okay, option C is the correct answer. Let's move to question number 5. The ratio of resolving power of an optical microscope for two wavelengths, that is lambda 1 6000 Angstrom and lambda 2 4000 Angstrom, is dash. Formula is resolving power is inversely proportional to wavelength. Okay, resolving power is inversely proportional to wavelength. Two different wavelengths is given. So RP1 is inversely proportional to lambda 1 and RP2 is inversely proportional to lambda 2. Then you want to find RP by RP1 by RP2. RP1 by RP2 equal to, what's the formula? Lambda 2 by lambda 1. Lambda 2 by lambda 1. What's the value of lambda 2? Lambda 2 is 4000 Angstrom into 10 power minus 10 divided by 6000 Angstrom. Simplify this. 10 power minus 10, 10 power minus 10, 3030 getting cancelled. 224, 236. Then what's the answer? RP1 by RP2 equal to 2 by 3. That is 2 is to 3. This is 2 is to 3, option C. Option C is the correct answer. Let's move to question number 6. A beam of light lambda equal to 600 nanometer from a distant source falls on a single slit of 1 meter wide and the resulting diffraction pattern is observed on a screen 2 meters away. The distance between first dark fringes on either side of the central bright fringe is dash. Formula x equal to 4 lambda by A. This is the formula. Then lambda is given how much? 4 into lambda is 600 nanometer. Nanometer convert into meter. 1 nanometer equal to 10 power minus 9 meter. So 600 into 10 power minus 9 divided by A. Value of A is 1 millimeter. 1 into 10 power minus 3. That is millimeter to meter. Then simplify this. 4, 6, 24. 24 into 10 power 2 into 10 power minus 9 into 10 power minus 3 comes up 10 power plus 3. Then x equal to 24 into 10 power 2, 10 power 3, 10 power 5, 10 power 5 into 10 power minus 9, 10 power minus 4. So 10 power minus, okay. And answer is given in millimeter or centimeter. So if you try for millimeter means 24 into 10 power minus 1 into 10 power 3. 24 into 10 power minus 1 into 10 power minus 3. 10 power minus 3 is meter. Then this is equal to 2.4 into 10 power minus 3 meter. That is 2.4 millimeter. 2.4 millimeter. That is option D. Option D is the correct answer. Let's move to last question. The angular resolution of a 12.2 centimeter diameter telescope at a wavelength of 5000 Angstrom is of the order of dash. Angular resolution formula d theta equal to 1.22 lambda by d. Lambda is given how much? 5000 Angstrom. That is 10 power minus 10 meter. And d is given 12.2 centimeter. 12.2 centimeter convert to meter. 10 power minus 2 meter. Then substitute this here. D theta equal to 1.22 into lambda is 5000 into 10 power minus 10 divided by 12.2 into 10 power minus 2. Now, simplify this. 1.22, this 10 times. Okay. Now, 5000 into 10 power minus 10. 5000 I can write as 5 into 10 power 3 into 10 power minus 10 into 10 power minus 10 into 10 into 10 power minus 2, 10 power minus 1 comes up 10 power 1 into 10. And if you simplify this, 5 into 10 power 4 into 10 power minus 10 gives 5 into 10 power minus 6. This is approximately 10 power minus 6 unit radian. Which option? Option D. Option D is the correct answer. Okay. Thank you, students. In next session, we will see next chapter in problem solving session. Thank you.